Now we're going to look at vectors, and hopefully this will be largely a review for most of you. Specifically, we're going to look at how do we represent vectors, how do we add and subtract them, and then basically how do we multiply them. First, representing vectors. We can do this by basically drawing a picture. So the vector, which is a quantity that has a magnitude and direction, the direction will be the direction we point an arrow in, and the magnitude will be the length of the vector. So vectors with big magnitudes will be long vectors. Vectors with small magnitudes will be short arrows. And we can point them in any direction we want. So that's one way, just to draw a picture with an arrow. We can also represent them numerically by giving the coordinates of the endpoint. This is often called the tip right here, and this is often called the tail because it's literally an arrow, and this is the tip of the arrow, and that's the tail of the arrow. And we can give the x coordinates and the y coordinates of the tip, and those are basically the components of the vector. Or we can give essentially the polar coordinates, which is the length of the vector and this angle. And we can tie those two together by using some trig and some Pythagoras, the connection between the polar representation and the Cartesian representation. Hopefully, that is all review. So what I want you to do is do a little bit of practice and answer these 6 little problems. This one you're going to draw a picture, so you can't enter that. But I want you to do these 2 calculations right here and enter them into the little box that will appear. And then look at the answers. Okay, first, the pictures. We want to draw the first arrow, so we're going to use the x and y coordinates, -4 plus 2, and then draw an arrow from the origin to the end. So that's the first vector. Second vector, we have the magnitude, and then we simply use this angle to represent its direction. So that's an angle pointed down in this direction. This is kind of, if you will, a northwest, and this is kind of a southwest. These are the solutions for the other 2 problems, finding the components and finding the magnitude and the directions. Notice that these 2 angles are perfectly equivalent. We can either represent it as a positive angle going counterclockwise from the x-axis or a negative angle going clockwise from the x-axis. But these angles would both be represented from the x-axis, and I can go around either way, and both angles are perfectly acceptable. This one is probably a little more informative because it says it's a little bit more than 90 degrees below. But both are acceptable. So that's just representing vectors. Next thing we can do are add vectors. And we can add vectors by drawing pictures, or we can add vectors by doing calculations. The most straightforward way to add vectors is a method called tip to tail. So we literally draw the 2 vectors. So here's one vector, and we draw it, magnitude and direction. The second vector begins at the tip of the first vector. So here's my second vector. We start right here, and we draw the second vector. And this again would be its magnitude and direction. The sum is kind of like, imagine you walk in this direction, then you walk in that direction, and the sum is what is the single path you could have taken to get to your destination, and that would be going straight from the beginning of the first to the end of the second. So this green vector right here would be the sum of the 2. So this is adding them tip to tail, and this right here is tip to tail. Make sure you don't add them so both their tails are together, and then connect the tips, because then you won't get their sum. We can also treat subtraction as just adding the inverse. So if I want to subtract a minus b, that's the same as taking a and adding the inverse of b. The inverse of b is just the same vector flipped around 180 degrees. So this right here is minus b. It has the same length, it's just in the exact opposite direction. And again, we're going to draw it at the tip of vector a. The sum goes from the beginning of the first to the end of the second. So we could call that vector d is the difference of the 2 vectors. So this right here would be d. We can also calculate it numerically. Here we have to break the vectors into their components, and we simply add their components. And if we're subtracting them, we subtract their components. Once I have the components of their sum, we can then get the magnitude and direction of their sum. And again, hopefully that is largely review. So do some practice, add these two vectors graphically, and then add these vectors numerically and find the magnitude and direction of both. And when you're done, this one right here, number 2, put in the little box on the side. Okay, to add these two vectors, notice they're not drawn correctly. They're, if you will, tail to tail. I have to take vector B and move it down here, or equivalently, I could take vector A and move it over there. But I'll move vector B over here. So now we're starting here, going down here, then going down there. That is exactly the same as starting here and ending there. So there's my sum. A plus B is this green vector right here. That would be adding them graphically. Note when you add vectors graphically, they form a triangle. And we can then use trigonometry to find out information about the vectors. If we know some of the angles and the sides, we can use the law of sines and the law of cosines, and we'll take advantage of that. But the key thing is the sum of two vectors always forms a triangle. Now, here are the solutions to the other two numerical problems. Notice this is the magnitude and direction. This is just adding the components. This angle is a little bit more than 90 degrees. This one right here, notice that's -2 and -12, so the magnitude is 12.2. One way to look at its direction is it's -99.5 degrees, which is down here, or again, we could represent the angle as the opposite side going around the positive direction above the x-axis. Again, both angles are perfectly acceptable. I find this angle right here, the -99.5, to be a little more informative because it tells me it's a little bit more than 90 degrees.